standard in and standard out in socket 3, and instead it will use the pipes. In other words, I'm changing the program to use pipes, but I'm preserving everything else exactly the same as socket 3. So this way, I can double check and make sure that I can reproduce the same behavior using pipes and not just standard in, standard out, and still be able to reproduce exactly the same behavior. So I don't, I know my logic is, or the switch to use pipes did not introduce any problems. Yep.
How did you test the timeout on write for your clients? Because I tried doing
Control S.
Well, you can't control S because you don't have. I mean, you don't have.
You have to control S on the outgoing side of the pipe.
Well, I mean, when you're doing forks, not on this, but when you fork off the clients, you don't have a console to attach to. So you can't.
But you can cat.
Oh, so you can still cat C out and control S that.
Yep.
Oh.
So when you get to the actual socket 4, which we'll probably do that also. So you run this on one terminal, which will start up the server process and also the 3 client process. So it makes no sense at all to do anything in this terminal. So this terminal is we'll just leave it alone. So what you can do is in another terminal, you can say cat redirect from, and let's say C1 in.
Yeah, I did that.
I
tried to stop it by using kill-stop in the PID, but then wait PID didn't return. So what I ended up doing is just not even catting out the output file and just running in a big old file.
I did this, and when it's catting it, I type a Control S on this terminal, and then on the other terminal, I keep catting like a big file, like socket4.c, the source file to it, until that can no longer be done.
Well, I found if you don't open the pipes, like if you don't cat out the pipes, it'll fill it up, and then it will time out on write.
Right.
So,
Right. So it will still, I can still reproduce the right timeout condition with pipes. But the key to do it, is to introduce small changes. So I just changed the same program to use, everything is the same, but this time I use pipes instead of standard in, standard out, and I try to make sure that all the same behavior of the previous version are still preserved. In other words, I don't make a whole lot of big changes all at the same time. Every time I make one change, it is one single feature of the program. It should not have impact to the other features of the program. You can see that I did not even introduce fork until like the very end, and the signal was the last one. Okay, I did not put any signal handling until pretty much the last revision of this program. Okay, so get out of this one. We will just go ahead and just quickly go over all the revisions. Okay, so this one is the first. Let's see, what did I change here? This one is not I reverted a change back to what it was before. I did not put a -1 into the socket FD. That has to do with the scanning mechanism not liking it. Okay, but here we have a major change to client relay. You can actually see, graphically, you can compare the old client relay and the new client relay. And all this code here in blue, those are all new code. And this is the version that actually introduced or changes the behavior by using the pipes instead of standard in and standard out. This is where that change occurred. And I verified that it did not change the behavior of the program. It just took more stuff to fill up the pipe so that it will stall the write process. And then the server will still time out. It just took more, it took more content to fill up the pipe at this point. So you can basically see all the highlight of the changes. Before it was using file descriptor 0 for standard in, and now it's using the pipe in file descriptor instead of standard in. But other than that, the program kept exactly the same structure as last time in terms of the use of select. It is the same as last time. The server code has no change at this point, with this particular version. Okay. Any questions at this point? Yep.
How much content did it take for your pipe to fill up? 'Cause every time I tried it, it seemed like it could take pretty much the whole thing.
I just plugged in a DVD.
It's huge.
That was huge, massive.
I piped in.
64-bit machine, so.
I piped in the source code of the program.
Yeah.
Probably about 15 times or so, before
I
it
think
fills
I
up.
did it once.
It's
so.
ulimit-P2, it shows you like, it gives you a number, and that number is times 512 bytes, and that's the size of your pipe file, I think.
Okay, can you change that? I mean, can you reset it
Yeah,
to
you have to do it with ulimit, I think you can with ulimit, but I'm not sure.
Okay. Now, would that only be applied to a particular shell, or would it be a system-wide change?
I think it's per user account from ulimit.
Okay, but not a per shell type of setting, it's a per user setting.
Yeah, for
Yeah.
everyone on
That's
your
not gonna
account,
be
it
good.
enacts immediately until you log out, and then you default back to system settings from
I see.
ulimit.
Okay, so we are moving back in time, moving forward again
Couldn't you like use a variable?
to,
Specify n and n minus 1, and then just change n at the beginning of it, and you put I
Yes.
and I minus 1, or n and n minus 1, and have it go faster?
yes. Okay, so this one introduced a few more stuff here. You can see that the structure is now getting a little bit bigger. It has a read time left and a write time left. In other words, I've introduced two more things to keep track of. With this particular client, how much time does it have before I time out in terms of read?
How do you do that with just an int? Only worry about
Well,
seconds?
you will see that that's going to change too. With just an int, it's going to keep track of seconds, but it's not going to be just that. It will just change later on. It has a write time left, which is used for keeping track of the write timeout, which was 10 seconds. And this time, I'm not even sure that this version actually makes use of these two. And it has a last one. The last one is important. It keeps track of whether a particular client is still alive, which is basically nothing more than a filter to say, should I even pay attention to this entry in the array? Okay. If you use a more fancy data structure like a list or something like that that can actually support deletion of a node, then you don't need that because you can just remove a particular client structure from the list and you're done with it. I was lazy last night and did not do it in the proper way in data structure. So. And okay, that's basically it. I just keep track of the alive, and I assign alive to be 1 when I initialize the client. That's all I did with this revision. So you can see that some of these revisions are not really major. They're fairly minor revisions, but basically every time I think I made a significant change, I would test the program again, compile, run it, test it again, and then I will commit. So I have, I know in the worst case I cannot revert it. Yep. Okay. So now we have, oh, did I change the number? Yes, I did. Okay, so here we have, you will see that this will change also. I made a new function called min time to basically look at how much time is left of all the read amount of time left, the write amount of time left of all the clients. So this is just a loop going through every single client, and it will try to find the minimum amount of time in terms of all the read amount of time left and all the write amount of time left. Okay, it's just an idea. Okay, it was not really used or called, but I was thinking, okay, it might be helpful for me to keep track of how much time is left for each socket operation has left. Okay, are you guys understanding what this is about or what it is trying to do? This is not the last version. You will see changes to this subroutine as we go on. And that was the only change. I added a function that I did not call.